GMAT all day.
In the last video, we saw that when you are trying to find the catch-up rate, the rate at which one person is catching up to another person, you have to find the difference of their individual rates. In this problem, we will be doing a combined or additive rate problem, and it should make sense that if you have two things working together now, you have to add their rates. So the only thing you really need to understand about this question is that if you have two machines, for example, and one can make widgets at a rate of 5 widgets per minute, and another machine can make widgets at a rate of 2 widgets per minute, then after 1 minute, they will have made 7 widgets together, and that is their combined rate. So as long as that makes sense, that is really the only thing that is different about this problem. And additive rate problems are by far the most common type of rate problems on the GMAT. So this question says, two painters, Mario and Luigi, are working together at independent rates to paint a warehouse. If the pair starts painting at the same time at their normal rates, they will complete the job in 180 minutes. However, if Mario eats a magic mushroom before starting the job, he could work at twice Luigi's rate, and the job would only take 150 minutes. How long would it take Mario, working at his normal rate by himself, to paint the warehouse? So for this question, just like we've been doing, I will organize my information in a table. Now remember, the point of the table, it is not a magic table, so the goal is not to fill out the entire table and then have it spit out the answer for me. I just want to organize the information that they do give me. So you have to think of the table as simply a way of organizing information. The goal is not to fill out the table. The goal is really to make equations, to translate words into algebra or words into equations that you can do algebra on. And so in this case, we have 3 players. We have Mario, we have Luigi, and then we have Mario plus Luigi working together. And so let's go through and fill in our table, each piece of information they give us. So everything they tell you in a rate problem, it's going to be one of 3 things. They're either going to give you some rate, some time, or some amount of work. And so the real thinking that you have to do is sorting out which rate and which time, which work are they giving you, or are they asking you for. So here they say if they start painting at the same time at their normal rates, together they will complete the job in 180 minutes. So oftentimes I ask people, what is this? Is this a rate? Is this a time? Or is this some amount of work? And usually what people say is, well, this is a time, because minutes is a unit of time. But this is really what I mean when I say the only thing you need to understand for rate problems is this equation here. Rate times time is equal to work, and you should understand it intuitively. So by that I mean, when I read this, I don't really see this as a time. I think of this as a rate, because time is usually the actual amount of time that the machine ran for, or the person worked for, or the time they're asking you to solve for. This here is more like it is a hypothetical time, or it is the time it takes to do a certain amount of work. And to me, that is a rate. And so when I read this, this is their combined rate. But the rate, we not want to write 180 minutes, because minutes is not a unit of rate. Rate is work over time. And so our work is in terms of one job, right? Or one warehouse. And so the rate isn't 180 minutes. It is one job per 180 minutes. Now, you can think of this as a time, but what you would have to sort of do is make a separate table off to the side here and say you had them working together. The time is 180 minutes, but that is the time for them to do one job. And then the only reason you would be filling this in is so that you could calculate this rate here. So I say cut out the middleman and just think of it as a rate to begin with. And it's also true, and I think this is actually an important property of rate problems. If you were given the choice to be given one of these 3 things, rate, time, or work, you would always want to have the rate, because rates are static. If you have someone's rate, that rate does not change unless they tell you that the rate changes. And so that rate is going to be the same rate. If the car is going at 20 miles per hour, it's going at 20 miles per hour after 10 minutes, after 20 minutes, after 1 hour. And so you can plug that in to any situation. And so if you could think of this as a time, but I would say I prefer to think of it as a rate because that rate stays the same. Then they say, however, if Mario eats a magic mushroom, he can work at twice Luigi's rate and the job would only take 150 minutes. And so this is also what I'm getting to when I say the goal is not to just fill in the table. The goal is to make equations because where would we fill that in? This is another rate and it's another combined rate, which we already filled in here. And so there really is no place for it in the table. But if you think of the goal as being, we just want to make equations, but we already have one equation, right? Because this is an additive rate problem. So if we were to say Mario works at rate M, Luigi works at rate L, well, from this first sentence, we know Mario plus Luigi, so Mario's rate plus Luigi's rate is equal to their combined rate of one job every 180 minutes. Now we have this other combined rate of one job per 150 minutes. But this is when Mario is working at twice Luigi's rate. So really we just have another equation where he's still working at his rate L, but Mario is now equal to 2L. So you don't need to put this information necessarily into the table. You can just make an equation from it based on the first equation. And so now here, what are they asking for now? Now we want to know how long would it take Mario at his normal rate to paint the warehouse. So they're asking for a time, and they're asking for Mario's individual time. We need to be using his individual rate, which is what M is. We're solving for this here. And based on the equations that we made here, before I have even done really any arithmetic, I can see exactly how this is going to play out. I can use this equation here to get Luigi's individual rate. Then I can plug that into this equation here to get to Mario's individual rate. And then once I have Mario's rate, I can get his time because we are looking for the time for Mario to do one job. So I can fill that in here because that is how we are measuring our work. And so once I have his rate, I should be able to get his time. And so let's now do that. So from here, we know that 3L is equal to 1 over 150. And this is why it's helpful, especially with the rates, to write out your units, at least to start, that you can remember what this 1 over 150 means. It means one job per 150 minutes. And therefore, if we divide each side by 3, Luigi's individual rate is one job per 450 minutes. Now plug that in here, we get Mario plus Luigi's rate, which is one job for 450 minutes. Is equal to their combined rate of one job per 180 minutes. So Mario's rate should be equal to 1 over 180 minus 1 over 450. So here is where understanding fractions is necessary. If you are thinking, oh, this is going to give me a negative number here, a negative rate, that is not true, so do not panic. 1 over 450 is less than 1 over 180. So we are all good here. This should give us a normal positive rate. But what we do have to do is we need to get a common denominator. So what is the common denominator between 180 and 450? It should be similar to just getting a common denominator between 18 and 45. And I believe 18 goes into 90 5 times. So if 18 and 45 have a common denominator of 90, 180 and 450 should have a common denominator of 900. So I need to multiply this by 5 over 5 to get a common denominator of 900 here, and a 2 over 2, get 900 over here, and I have 5 over 900 minus 2 over 900. So remember what this is saying. We are saying one job every 180 minutes is equivalent to 5 jobs every 900 minutes. And one job per 450 minutes is the equivalent to 2 jobs per 900 minutes. And so that means Mario's individual rate is 3 jobs per 900 minutes, which is equivalent to, if we simplify this, one job per 300 minutes. You can also think of this, if you want to do, as 1/300th of a job per minute, but I like this way better. And so now we don't even really need to calculate Mario's time, because we have his rate in terms of one job, which is the time we are looking for. And so really his time is just the bottom portion of our rate here. It takes him 300 minutes to paint the warehouse by himself. And so looks like we now just got to convert that to hours. So 300 minutes. And we have 1 hour is equal to 60 minutes. And we want our minutes to cancel out. So we put it on the bottom. That leaves us with 300 over 60, which is just 5 hours. C.